Now we're going to enter the trick shot zone. We're going to take this guy not from beyond 2F, not at 2F, no, not even 2F to F. Even at F, they took it to where they said it couldn't be done. He took it bravely to a position between the focus and the lens itself. And lo and behold, we can still do the one straight one through, unlike the mirrors. We can actually still draw that one. That's amazing. And unlike the mirror, we can still do this one. You got 2 out of 3 marks without using a trick shot. But wait, there's more. Could you, in fact, draw the arrow from the focus through this and out? It looks possible, but it misses the lens. But let's just wait on that for a minute. Look at these two guys. They don't really come together, but once again, your brain is so clever, even when the rest of you doesn't feel like it. Your brain can go, I know where those came from. They came from back there. And your brain says, this one here, I know where it came from. It comes from back here. And your brain backtracks it. What you can do that I have to do in 2 steps is put the gray or a dotted line there, because this light here, can't do that. This light here does not exist. And this is where it gets a little bit awkward. This black beam here most definitely left the arrow tip and went that way. But when it comes out, it's going this way. And your brain thought it came from back here. And it certainly did in this segment, but this part is imaginary. This beam was located here. When it took off that way, your brain was the one that thought it continued to come from behind the mirror. It really came this way, not mirror, lens. Your brain thinks it came from back there. It mistook its actual direction. So this means you think you saw this thing way out here. It's gigantic. Now, where are you? Your eyeball is somewhere out here looking. Okay? So if I want to draw your eyeball, we just go and do this. We go, nice line, and then we draw that little arc segment in here to indicate an eyeball like that. A drunk eyeball, I guess. You might go, but geez, none of these rays of light are going into this eyeball. It's not a scale diagram. On the scale of this, your eye is huge. It's meters away. It doesn't matter. You are watching these beams, and what you think you see is a gigantic image on the other side. You cannot see this black arrow here. That's not what you're seeing. You'd have to take the lens away to directly see it. The light from the actual object has spread way out to the right here. So while it really is this size, the way the light has been distorted, this is the part you see. You don't see a little arrow with a gigantic one behind it. This is simply produced a new object here for you. You can't see 2, right? On a mirror, you can see both of them at the same time, the real object and the reflected one. Not on the lenses. On the lenses, you're on the opposite side of the lens. You cannot see the original object. You would have to peer over top the lens to see it. This is the most common mistake for misunderstanding, and I'm hammering on that right now, because if you don't understand that, these diagrams are a waste of time. So this is for an object which is much closer than the focus, or we can just say closer than the focus. This makes an image that's huge, and its attitude is upright. Its location between 2F and F on the original size of mirror, original side, and its type is now virtual, because virtual is the letter V. Okay? V for spreading. So if I try to draw the letter V, look at that. It's like rays of light spreading apart. This image cannot be projected, but your clever little brain backtracks these. Now, what about that third ray we were talking about? Well, if a beam of light left the arrow tip on such of an angle that it seemed to come from F, so it really started from the arrow tip, but it looks like it came from F, see? But it didn't. It started here. It went that way, only it looked like it came from there. But it didn't. It started here, went that way. But, how do I connect these? I can't on this program. But you can at your desk. You go like that. And what you have to realize is this light here is not there. That was just me needing to do it on screen. What happens when you go in on the angle like you came from F? You leave parallel. And your brain goes, you sneaky devil, you came back from there. And look at that, how close it came. It almost worked. But why? Look at, I'm off here. There you go. What's this one for? It is the first time you ever became familiar with lenses. This is a magnifying glass. You take an object, hold it extremely close to the magnifying glass, and it spreads the light out. So when you're standing out here somewhere, you see a gigantic magnified version. This is the second hardest ray diagram that exists. And here endeth the lesson.